From the void, another messenger has arrived. I'm Atlas. Like one eye, Oumuamua, and two eye, Borisov before it, this object is an outcast from another star system, following a hyperbolic path that will see it visit our solar system only once. But unlike its predecessors, 3i Atlas is a puzzle defined not by its shape or its speed, but by its color, and more importantly, by how that color is about to change. So, verified facts and dates. When 3i Atlas was first discovered in the cold outer reaches of our solar system, it was faint. Telescopes measured its light, and they found a distinct spectral signature. It was red, not just a little red, but deeply, profoundly red. This color is a date stamp. Plausible mechanisms. For the millions, perhaps billions of years it spent tumbling through interstellar space, it was constantly bombarded, not by asteroids, but by radiation. Cosmic rays and high-energy ultraviolet light from distant, hot stars relentlessly cooked its surface. This process, called irradiation, is a form of cosmic chemistry. It takes simple, primordial ices, like methane, ammonia, and carbon dioxide, and breaks their chemical bonds. They reform into complex, heavy, carbon-rich organic molecules. We call this material tholins. Tholins are a dark, sticky, reddish-brown sludge. They cover vast regions of Pluto. They form the haze of Saturn's moon Titan, and they appear to coat the surfaces of most cold, distant objects. Atlas, an object that has spent most of its life in the interstellar deep freeze, is covered in them. This red tholin layer is a crust, an ancient insulating skin that tells the story of its long, lonely journey between the stars. This crust is a mask. It hides the comet's true nature, and as 3i Atlas falls toward our sun, that mask is about to be burned away. Verified facts and dates. The story of its transformation began far from the sun, even before it reached Saturn. Astronomers detected a faint but distinct coma. This was not a water ice coma. It was too cold for that. It was a coma dominated by carbon dioxide, CO2. This was the first clue. Plausible mechanisms. The sun's energy, though weak, had already found small cracks in that red armor. It was heating the pristine, volatile ices below the crust, and CO2 gas was forcing its way out. The red traveler was already beginning to wake up. The 2025 encounter is not just an observation, it is an autopsy of this ancient crust, a time series experiment that will track the object as its identity shifts from a static red rock to a dynamic, evolving world. As 3i Atlas crossed the orbit of Mars, the game changed. Verified facts and dates. The Mars flyby on October 3rd, 2025, provided a ringside seat for our robotic fleet. The comet, once a cold red rock, was now a dynamic, active world. The sun's energy, even at this distance, was intensifying. This is where the transformation accelerated. Plausible mechanisms. The CO2 sublimation, which began as tiny seeps in the outer system, was now explosive. The pressure built beneath the ancient, brittle tholin crust. That red, irradiated armor began to crack, fail, and break apart. Imagine a frozen lake, its surface covered in red dust, suddenly cracking open from the pressure of a geyser below. This is what our Mars orbiters witnessed. Active regions, newly formed pits and fissures, were venting CO2 gas and fine dust directly into space. This process did two things. First, it sandblasted the surrounding surface, scouring away the red tholin crust and revealing the pristine, bright, primordial ices hidden beneath. The comet was shedding its interstellar skin. Second, it fundamentally changed the color of its atmosphere. Plausible mechanisms. The CO2 jets were not just spewing gas, they were dredging up other, more complex frozen molecules from the nucleus. As these molecules were hit by intense solar ultraviolet radiation, they were systematically destroyed. This destruction, this photodissociation, created a swarm of molecular fragments in the coma. Among them was diatomic carbon, or C2. C2 is special. It is a molecule that is perfectly tuned to absorb solar radiation and re-emit it as a ghostly, specific shade of green. Verified facts and dates. This is the famous green glow of comets, a fluorescence process known as the swan bands. Suddenly, 3I Atlas presented a stunning contradiction. At its heart was a nucleus, still predominantly reddish-brown, where the ancient tholin crust remained intact. But this red heart was now shrouded in a vibrant, expanding green coma. This is the shift scientists were tracking. Verified facts and dates. Using time series color indices, a precise measurement of the comet's brightness through different colored filters, they watched the coma's integrated color swing dramatically. The data plot, which for a year had sat in the red quadrant, now marched decisively into the green. 3I Atlas had gone from red to green, a visible signal that its surface was disintegrating, its interior was being exposed, and its true, volatile nature was being unleashed for the first time in a billion years. The green coma tells us that the comet is active. The nucleus tells us where. In part 2, the red to green shift described the coma, the cloud of gas surrounding the nucleus. This was a chemical change, the creation of C2 diatomic carbon, from the explosive release of CO2. But to understand the engine, we must ignore the green exhaust and focus on the motor itself, the nucleus. This is a profound observational challenge. Plausible mechanisms. We must digitally subtract the overwhelming glare of the green coma to isolate the faint reflected light from the solid body at its center. When we do this, the nucleus of 3I Atlas reveals itself. It is not one color, it is a mosaic. Verified facts and dates, data from the Mars flyby, combined with time series observations from Hubble, allows us to build a crude map. Most of the surface is the ancient dark reddish-brown tholin crust from Part 1. This is the interstellar surface, irradiated for eons. But as the comet rotates, we see its brightness change. This is called a light curve. Plausible mechanisms. The light curve of 3I Atlas shows distinct peaks. These peaks correspond to a massive, new, active region that has been exposed. A region where the red crust has collapsed, revealing the pristine, primordial ice beneath.
Matches the brightness graph.
And what color is this fresh ice? To a color index telescope, it is blue. This doesn't mean it's the color of the sky. It means it is less red. The ancient tholin crust strongly reflects red light. The fresh ice, by contrast, reflects all wavelengths of light more or less equally. This lack of redness registers as a blue index. This is the key. Testable predictions. As the comet rotates, we can watch its integrated color index shift in real time. When the dark red side faces us, the nucleus is dim and its color index is red. As the bright fresh ice patch rotates into view, the nucleus brightens and its color index simultaneously shifts to blue. The blue patch is the active region. It is the source of the CO2 jets. It is the engine that is creating the green coma. The red to green shift of the coma is caused by the red to blue shift of the nucleus surface. Plausible mechanisms. We are witnessing the birth of a cometary caldera, the CO2 sublimation front, the layer where the ice boils, is meters below the insulating red crust. As the pressure builds, it doesn't just seep out, it catastrophically destabilizes the crust above it. A vast sinkhole forms, collapsing the red tholins and exposing a massive fresh patch of CO2 ice. This new, bright, blue region becomes the dominant source of activity. We are no longer observing a simple, uniform object. We are mapping the geography of an alien world as it tears itself apart. The transformation from red to green was just the prelude. The main event is perihelion. Verified facts and dates. Around October the 29th, 2025, 3 Atlas will make its closest approach to the Sun. This is the point of maximum heating, maximum stress, and maximum violence. Testable predictions. Based on the caldera collapse model from Part 3, we can make a clear prediction. At perihelion, the Sun's heat will become so intense that the ancient red tholin crust will fail catastrophically. It won't just crack, it will be obliterated, sloughing off in vast sheets. This will expose the majority of the nucleus, revealing its pristine, blue-white, CO2 ice interior. The blue active regions will no longer be isolated patches. They will become the dominant terrain. This predicts 2 simultaneous dramatic color shifts. 1. The nucleus itself will shift from mostly red to overwhelmingly blue on its color index. The coma, fed by this massive new exposure of CO2 ice, will explode. The production of green glowing C2 will skyrocket, making the comet's green halo exponentially brighter. This is the great transformation the moment the comet sheds its interstellar identity. It's the climax of our time series experiment, and we will miss it. Verified facts and dates. The scientific cruelty of this orbit is that perihelion occurs after the solar superior conjunction on October the 21st, 2025. The comet is at its most active, its colors shifting most rapidly, precisely when it is hidden behind the Sun's blinding glare. The red to green timeline, which we have so carefully built, hits a data gap at the most critical moment. This is where the Hubble gambit from our previous script becomes essential. Verified facts and dates. Only Hubble, using the Earth as a shield, can attempt to point into this forbidden zone. But its goal is not just to see the comet. Its goal is to measure this specific predicted color shift. Plausible mechanisms. The observation is a battle of colors. The data Hubble gets is a composite. It will see the green light from the new explosive C2 coma, but it will also see red light. This red light is the anti-tail, a spike of old reddish tholin dust grains that the comet shed months or years ago, now seen edge-on, muddy. The entire scientific goal of the conjunction observation is to disentangle these 2 signals. By using different filters, astronomers must measure the ratio of new green gas, the C2 fluorescence, to old red dust, the tholin anti-tail. If this green to red ratio is sky high, it confirms our prediction that the nucleus has flipped to a new hyperactive blue state, shedding its ancient crust in the Sun's fire. For weeks, silence. As 3 Atlas passed through perihelion, it was lost in the solar blackout, leaving the scientific community with nothing but predictions. The central question remained, did the red crust survive the fire, or was it shed, revealing a new blue nucleus? Verified facts and dates. In December 2025, the comet was recovered. As it cleared the Sun's glare, ground-based observatories around the world raced to acquire the first post-perihelion data. This was the moment of truth for the color shift hypothesis. The verdict was immediate and unambiguous. The red to green shift of the coma was not only confirmed, but the C2 diatomic carbon signal was overwhelming. The green glow, fed by the catastrophic sublimation of new ice, was now the comet's dominant feature. More importantly, the nucleus itself was measured. Testable predictions. The time series color index, once a red value, had plummeted. The new data points landed squarely in the blue or spectrally neutral zone. The prediction was correct. The ancient, irradiated tholin crust had been shed. The object that emerged from the sun's glare was, physically, a new comet, its surface now dominated by the bright, pristine ices of its interior. But in science, a measurement is only as good as its error bars. How do we know this blue color is real? Plausible mechanisms. This is the discipline of data hygiene, the guardrail against false discovery. The primary challenge is called photometric calibration. Every camera, every filter, every telescope mirror has its own unique, imperfect color signature. It might naturally make things look slightly redder or slightly bluer than they are. To measure the true color of 3I Atlas, you must first measure your own instrument. Verified facts and dates. The protocol is rigid. An observatory measures the color of 3I Atlas. Then, it immediately slews to a nearby standard star, a star whose color and brightness have been mapped and are known to an absolute, unchanging value. By comparing the measured color of this standard star to its known true color, astronomers can create an error map. They can precisely calculate how much false red or false blue their instrument is adding. This error map is then subtracted from the comet data. Comet plus error. Error. True comet. Verified facts and dates. This process, observation, calibration, peer review, and replication by a separate team on a different telescope, takes weeks. This is the institutional delay that is vital for accuracy. The results were cross-checked. The red to blue shift of the nucleus is real. The red to green explosion of the coma is real. We have successfully tracked the violent death of an ancient interstellar crust and the birth of a new active comet. The transformation is complete. The object now coasting into the outer solar system is not the one that arrived. The red, ancient, irradiated visitor is gone, its skin shed in the solar fire. In its place is a new, blue, pristine nucleus, a raw, exposed piece of another star's primordial cloud. This transformation is the entire legacy of 3I Atlas. It proves that a comet's surface is a mask, and that to understand its origin, you must be there when the mask is removed. Verified facts and dates. This new comet now faces its final and most important chemical analysis. On March 16, 2026, the comet's geometry relative to Earth and Jupiter provides a perfect, clear viewing window for the James Webb Space Telescope. Plausible mechanisms. JWST, with its powerful infrared spectrometers, will now perform the definitive chemical autopsy. Hubble's color index was a blunt tool. It told us the surface changed. JWST's spectrographs will tell us what that new surface is made of. This is the payoff. The CO2 dominance, which triggered the green coma, will be quantified. Its abundance measured against the newly released water ice, H2. But the ultimate test will be for the nickel-iron anomaly.
It's much clearer
Testable
now.
predictions. The Mars flyby in October 2025 detected hints of nickel, Ni, without iron, Phi. But that was from gas seeping through the old red crust. We didn't know if this anomaly was a real bulk property of the comet or just some strange superficial surface chemistry caused by eons of irradiation. The JWST observation solves this. Verified facts and dates. JWST is now observing the pristine interior. If the nickel without iron signature is confirmed in the gas sublimating from this new blue ice, it is not superficial. It is fundamental. It means 3 Atlas was formed in a part of its home star system that was chemically bizarre by our standards, a region perhaps astonishingly poor in iron, or where nickel formed exotic compounds that iron did not. This is the power of the time series. We didn't just observe a comet, we observed a metamorphosis. We used its red to green, coma, and red to blue, a Re-nucleus shifts to track the precise moment its ancient armor failed, and then directed our most powerful assets to analyze the pristine interior that was exposed. Verified facts and dates? When Oumuamua was a red rocky enigma, Borisov was a reddish, co-rich comet. Atlas was a 2-for-1 specimen. We got to study an ancient, irradiated red tholin crust, and then, after perihelion, a pristine blue, $2 ice interior. As 3II Atlas tumbles back into the cold, its new blue surface will slowly dim, its jets refreezing, a permanent scar from its fiery passage. It leaves us with a profound new understanding that the galaxy is not just sending us visitors, it is sending us puzzles that change their own shape and color right before our eyes.